turn on this. Does anyone else need a pencil? Pencils? Oh, Jacob, do you need a pencil?
Shoot.
Dude, what's your music on really loud?
I know, I hear it.
Jose, turn your music down. You're going to blow out your eardrums. Okay. So today and for this unit, we're going to be drawing a lot of straight lines. If you need a ruler, let me know. Or just like any kind of straight edge will work. Okay. So, does everyone remember Sloe from last year? Rise and run. Good. Okay. So we're going to talk about slope and how slope is like a rate of change today. Okay. So, first thing we want to do today is make a table of values for the graph y equals x minus 3. Okay. So we can put the x's anywhere and we can put the y's anywhere. Easiest thing to do is usually put 0 in the middle for your x and then go up and below 0. So go 0, 1, 2, go 0, -1, -2. Wait, is this real scroll with me? No, it's not. Okay, because really all you need to draw a straight line is 3 points, but having 5 just kind of reinforces what we're going to do. Okay, so we want to make a table of values for y equals x minus 3. So what we're going to do is have y equals x minus 3, and then we're just going to substitute in each value. Okay, so the first one I'm going to do is y equals, I'm going to take -2 minus 3. Okay, so I'm just going to sub in the first value I set for x. Okay, and then what's -2 minus 3? Perfect. It's -5. So my y value at -2 will be -5. Does that make sense? Take the value, sub it in for x. Okay, and then we'll draw a point. We can label this. We'll have 0, 1, 2, 3, 4, 5. -1, -2, -3, -4, -5, -6. So that would be 1 up there. This will be -1, -2, -3, -4, 5, -6, -7. Okay. So now I'm going to make a point at -2 and -5. So -2 can go all the way down to -5. There's my first point. Okay, now for my next point, I don't.
How about this one?
Yep.
We took that from you.
Oh,
That's the white eraser.
Oh.
White.
Okay, so for my next point, I don't need -2 anymore. Who said that? Louder. So it's a -1, right? Yeah.
So I don't need that anymore.
Oh, I thought you said -1.
What's -1?
My next x value is -1. Okay. So now my x is -1. -1 minus 3 is -4. Good. So I'll put -4 into my table of values. And now I'm at -1 down to -4.
That's why it should be -3, but then be adding 0.
Perfect. So next one. My x is 0. And then 0 minus 3, like Tristan said, is -3. Good point there. And then you can keep subbing it in if you want, but based on the pattern, where the next two numbers going to be. Yep. Perfect. It'll be -2 and -1. And you just keep going up. So keep adding 1 each time. Okay, so then we'll go to 1 and -2, and 2 and -1. So this is where the rulers come into play. If you want to borrow one, you can. But you just draw a straight line that connects all your points together. And then we like to put some arrows on the end to show that this line keeps going on forever in both directions. Okay? So even though we only did 5 points, the line extends on forever to positive infinity and to negative infinity. Yep. Yes. Anyone see a ruler?
You're such a picky
You say you're pregnant?
I am not pregnant. Cop does not know biology. The wife is pregnant, not me.
It's gonna happen today.
What?
It's gonna happen today.
What?
Like, is she gonna give birth?
No, not till October.
Oh. Oh, congrats.
Oh, thanks. Okay. Okay. What? Don't take phones. All right. Everyone, got a copy down?
Yes.
Perfect.
How do you do that?
What?
Erase the book. You just-
Oh, yeah, so if you have like a bunch of like stuff everywhere, if you see eraser and circle around everything and tap it, it'll disappear. But whatever you don't circle around stays there.
Oh, that's very interesting. Imagine you circle around, but you forgot it, you accidentally took the white part with your eraser.
If what?
Nothing. Didn't say anything. You're bad.
Pretty sure I found that out by accident.
Sorry.
Okay, so slope of a line. Okay, the slope of a line represented by M. Why is it represented by M?
It stands for measure.
It might, I don't know. The slope is M. It's probably comes from like Latin or something. But it's a measure of how steep the line is, okay? So if you have like a kind of really flat line, you have a very low slope. The steeper your line gets, the higher your slope gets, okay? Until it's vertical and slope is like infinite. Okay? So there's several different ways to determine the slope of a line. We can say m is slope, or we can say that it is rise over run. Rise over run. It's also the difference in our y-coordinates divided by the difference in our s-coordinates, which is just y2 minus y1, all divided by x2 minus x1. Okay? Rise over run is kind of like how we start you off with slope, but this is the way slope is actually represented. Okay? Because it's a change in y over your change in x. Okay? Is anyone planning on taking physics next year?
That's still
Physics.
What did you say? Sorry.
Is anyone planning on taking physics next year?
No.
Well, yeah, there's a lot of slope, and like we represent that as delta. And really, the further on you move with math, the more it kind of changes from subtraction to just a delta to a derivative. So in this example, we want to calculate the slope of a line AB. Does everyone remember that kind of line notation?
No.
So if you have 2 points A and B, we call the line between them AB. Okay? Because it would be negative, right? So if we have A and B, okay. Rule about the rulers. If you hit each other with them, I will take them away. That's the first and only warning. Okay. So if you have a point A and a point B, the line that connects them, we call it AB. Make sense? Because going from A to B. So simple line AB if A equals 6 and negative 9, and B is negative 4, 5. Okay? So which formula we're going to use? Rise over run, or y2 minus y1 over x2 minus x1. So actually it's easier to use the coordinates, right? If we have x1 and y1, and we have x2 and y2. Okay, so we're going to use our slope, m equals y2 minus y1 all over x2 minus x1. Okay? The thing with this is that you just want to keep all your numbers straight and remember which one goes to which, okay? So here, I'll do x1, I'm just going to circle in blue, y1, I'll circle in green, x2, red, and y2, black. Okay? So, which point or which number is my y2? 5. Good. Okay, so I'll have 5 minus, what's my y1? Negative 9, good. So, okay, guys, if your y1 or x1 is negative, put the brackets there, okay? Because remember, it's going to change. A negative times negative becomes a positive, right? So it's important. If you don't do that, you're going to get the wrong slope. All divided by, what's my x2? Not 5, that's y2.
Oh,
-4.
Perfect, -4. Okay, remember, the first slot position is always x, the second one is always y. So we'll have -4 minus, and my x1 is, Robbie?
6.
6. Perfect. Okay, so we take our y2 minus y1 and our x2 minus our x1. So 5 minus -6 would be what?
What?
Probably
14.
14, right? Because we're going to, it'll become 5 plus 9 over -4 minus 6.
Oh.
Right? Because 2 negatives make a positive. So like Robbie said, it'll be 14 all over -4. Take away another 6 will give us -10. Good. -10. I'm just going to finish it up here because we want it in lowest terms. So it's going to be negative because we only have the one negative. Divide by 2. So we get 7 over 5. So our slope equals -7 over 5. Page 2. Oh yeah, 2 or 3.
Why wasn't it 9?
Because the printer, or sorry, the photocopier, will not be my printer. Very nice.
Oh, I know.
Okay, everyone, good? Okay, first one on page 2. We want to calculate the slope of this line. I apologize, the line didn't work out perfectly on Word. So we're going to go from these points, okay? Right here and right here. So it's going to kind of make the points super big so that they end up being in the proper spots. Which I'm going to have to move it. Okay. This time it tells you to calculate using rise and run. Okay. So if I'm starting here, what's my rise? Start at the bottom, left, and I'm going up. Or do you want to do run first? If I start here and go all the way to here, what is my run? Not 2, not 0. How many do I go over? I go over 1, 2, 3. So my run is just how far I'm going left or right. Okay. And remember, run goes on the bottom, so I'm going to have divided by 3. Now, what my rise is how much I'm going up or down. What's the rise?
Robbie.
1.
Just 1, perfect. So I'll have 1 over 3. So that's just my slope. I can't reduce it down to any lower terms. Okay. So let's copy this down, then we'll have, I'll go more into that. Oh, I just grabbed it. Okay. So, rise directions. Rise is our Y directions. Okay? Or it's your up and down. Okay? So rise, just like when you kind of rise up
Like the sun.
from what?
Like the sun from the bottom.
Oh, I thought you said the song. I thought you were talking about Hamilton. I gotta really say it there. But yes, the sun rises up. Perfect. Okay? No, that's a great analogy. The sun rises up. Sorry, I thought you were referencing Hamilton. It's okay, buddy. Sun rises up and sets, okay? So it's going up and down. Okay? A run. When you run, do you run up in the air like the sun?
Oh no.
No. You run side to side.
Unless you're Mario.
Unless you're Mario. Okay. His rise is his jump, okay? And then he runs left to right. Okay, so this is your left and right. And then remember, it's always rise over run. Okay, so it's how far you go, divide by how high you're jumping or how low you're going. Okay, so always start at the leftmost point and go to the rightmost point. Okay. So, what is our, do you want to do rise or run first?
Rise.
Rise. Okay, so I'm starting here, and I have to go down to here. So I'm going down to here. Okay, so my rise is
5.
1, 2, 3, 4, 5. Good, but is it positive or negative 5?
Negative.
Negative, why? Perfect. Whenever you go down, you get a negative rise. Okay, so my rise will be negative 5. My run, I'm just going to start from here, over all the way to this point. Okay, so you should always reach your second point, whether you go rise first, then run, or sorry, rise and run, or run then rise. You always reach that point, and it's always going to look like a triangle. Okay, we're going to talk a lot about these right angle triangles in that 2 years from now. Right. So how far are we running here?
8.
1, 2, 3, 4, 5, 6, 7, 8. Perfect. Positive or negative? Positive. Good. Okay. So let's do this over here. Rise, going up is positive, and going down is negative. Run. Run is negative to the left and positive to the right. What are you doing?
He's touching.
Don't hands to yourself. No body contact. You learned that in like kindergarten. Okay. So rise. If it's going up, up is positive, down is negative. Run. To the right is positive, to the left is negative. Okay, so slope is rise over run. Our rise we said was -5. And our run was 8. Can we reduce this to lowest terms at all?
Maybe I don't know.
No, they're both. Well, 5 is a prime number, so it can't get any lower. And 8 is divisible by 5, so it's already in lowest terms. Okay. Usually, if they're both like even numbers, you can divide by 2, so then you can bring it down to lowest terms. Well, that's all that page.
We don't know their pain.
Oh, that
No, that's Leo.
Whoa, I think that's my pencil, buddy.
Oh, it worked.
Is this yours? Bro, we missed the end of Kung Fu Panda. We missed the end of Kung Fu Panda.
No. They would do.
Bro, look what you're watching.
Or just start telling people till you guys. Okay. This is our last example, yeah. So the last example. For the line, y equals -x plus 3. We want to make a table of values and graph the line. Then we'll use the graph to find the slope. I'll do that. Okay. So easiest thing to do is always start at 0 and then go 1 up, 1 up, 1 down, 1 down. Okay. You could use any numbers that you want for x, but usually whenever you have a graph, it's always going to have the origin and then numbers around it. So it's easiest just to start at 0, then go 1 up. If you want to go 0, 1, 2, 3, 4, 5, you could do that too. Doesn't matter. So y equals -x plus 3. So y equals negative and then plus 3. What's my first x value point I'm putting in? 1. We can put in 1, sure. So we can do y equals -1 plus 3. And what's the side equal? Yeah, -1 plus 3. Positive 2. Good. It's almost the same as 3 minus 1. Okay. So when it's x equals 1, we can do 2. Let's do 2. If x equals -2, what is y going to equal? 1. Good. Equals +1. Take these away. If x equals 0, y will equal yeah, the last example we did was -3, right? Yeah, that's from the first one. +3. So what do you think the next two are going to be? If we're going 1, 2, 3, this will be 4. This will be 5. Good. You can double check with math if you want, but once you see the pattern, you can start to fill in the blanks. Okay, so we're at -2 and +5, -1, +4, 0, 3, 2, 1. Okay, with the rulers, your line should look better than mine. Okay, now we want to find the slope. So do you want to use y2 minus y1 or rise over run? Find the slope. Where you're looking for slope. Okay. So do you want to use rise over run or y2 minus y1 over x2 minus x1? Rise over run? Okay. So let's start here. What point do you want to go to? We're at 2 and 5. What point do you want to go down to? Okay, let's go down to 0 then. That's probably easy. Like x equals 0. We'll go down, and we're at 0 here. So what is our rise? We're going from here to 0. We're at -2, 5, and 0 and 3. Perfect. Our rise is -2. Rise over run. Rise -2. What's my run? I'm going 2 to the right. So my run would be. If I'm going 2 to the right, it will be
1.
not 5, not 1. Going 1, 2.
Oh, 2.
2. Perfect. And what's -2 divided by +2?
1. -1.
Perfect. So our slope will be -1. So you could have picked any points, any of the 5-point combinations. They all would have worked. Actually, if you're doing 5, choose 2. If combination. Okay. Yeah. On the x, we have -1. So that's going to be our slope. So we'll start to talk more about that when we get into what the equation of the line is. Okay. There's just one last thing we have to do for today. Everyone got this down? So we want to calculate rates of change. So we calculate by subtracting the y value from the y value before it. Okay. It might seem kind of weird when we write it out like that, but once we actually do it, it should make more sense of that's what we're doing.
Please excuse interruption. At this time, we ask all grade 12s to please make their way to the large gym with their classes for our grad assembly. As you enter the gym, there are some sheets on both sides for you to pick up. So this time, all grade 12s, including those on spare, please make their way to the large gym.
What time?
Grad math for grade 12s.
Oh, those are walking.
Yeah, just don't go to the grade 12 grad math.
Oh, I don't plan on it.
Okay, yeah.
Thanks.
It's kind of suspicious how you
No.
ask what's going on.
Don't-
Once go to math.
Don't you worry, I'll stay on that one.
So here's what we do. We look at our y values that are two x's in a row. And what I'm going to do is I'm going to take the first one and subtract the second one. Okay, so 3 minus 1. And what's 3 minus 1? 2. Okay, so that's going to be our first difference or our rate of change. Okay, the next one. Actually, we'll keep the colors every time. This time I'm going to do 5 minus the 3, the one above it. Okay, and what's 5 minus 3? Also 2. Then I'll go 7 minus 5. And 7 minus 5 is 2. Okay. I'm going to erase this line. Okay, so rate of change. So this is called the first difference. Okay, guys, just 2 more seconds, okay? Because it's the first time we're taking the difference between our y values. Okay, the difference is subtraction, remember? Okay, and then linear relations. Always have the same first difference. Okay? Every time we took the first difference between the points, it was always 2. Okay, so whenever you have the first difference that's the same for all of them, that's going to be a linear equation. Okay? If the first differences are different, And then when you do what we call the second difference, if those are the same, then it's quadratic. Okay, if they're still not the same, they have exponential or logarithmic equation.